So good morning all of you. Today we are going to begin with the third unit, which is memory management in operating systems. In the first session or in the first unit, we covered the general objectives and functions of operating systems. We got an introduction to what is operating system, what are the functions that an operating system has to do in your computers. Not only in your computers, now in any devices. Almost you have IoT, you have robotic operating systems and so on coming up in this with the advancement of technology which is changing every day. We find different kinds of applications where we need operating systems. We have robotic operating system called as ROS, which is for robots. Okay, so the first unit we saw the general purpose and an overview of operating system. The second unit we studied a very important concept called as process management. What is meant by a process, how process is managed, and so on. The third important function or most important thing that an operating system does is all about memory management. If the processor is the heart of your system, memory is the brain of your system. Memory is where the information is stored, accessed, again stored, changed. All these process is happening within the memory. And memory is a limited resource. Limited resource means whenever you buy a computer or a mobile phone or whatever, you say you have now 128 GB. Okay. In 1999, the computer with a good memory was 1 MB. 1 MB computer was available once upon a time, long back. So the memory was very small, very little usage. Now we have GBs and terabytes. Now latest computers that is being released will be having 1 TB. Your mobile phones are having 256 GB or so on. So the amount of memory is being increased, and based on the memory, the price of your mobile phone also varies. Have you noticed that? When you want to buy a new mobile phone, when you go to an Amazon website or any other place and start searching for a mobile phone, 256 GB mobile phone would be much costlier than 128 GB mobile phone. That means that memory is valuable. Okay, so memory management is a very important function, and how memory is a very important resource of your system is what we'll be seeing in this particular session. Okay, so the memory management algorithms. So we have algorithms, we have it from the long term onwards. We have algorithms like memory segmentation, memory paging, and all sorts of memory allocation systems. So this is the overview of the third module or the third unit. We'll be studying what is meant by main memory. We'll be studying swapping. Swapping means exchange. Okay. What is memory swapping? What is contiguous memory allocation? What is meant by paging? How to structure a page table? What is meant by segmentation and paging? What is virtual memory? Demand paging, copy on write, page replacement, and allocation of frames, thrashing. These are the topics that we'll be covering in this particular unit. We'll be going through an overview of all these things. We have started with what is meant by memory management. Memory management is a very crucial component of operating system that handles allocation and deallocation of memory to the process differently. I'll explain to you. We have process P1, P2, and we have memory usage. Each process is allocated memory And memory is, see, after the purpose of P1 is over, P2 can use that same memory, right? Same way, this allocation and deallocation is done by the operating system. That is what this sentence means. Okay, the goal is to optimize the performance while ensuring fair resource distribution. That means that every process should be given same amount of importance. Same priority should be given, not that certain things is given more importance and certain things are not given importance. Okay, so the objective of main memory or the memory management systems in operating system is to ensure that all the processes are fairly being treated. Memory consists of large array of bytes and each with its own address. We need an address, right? We need to know from where one is sent, what is being sent, and how it is being utilized. So memory contains a large array of bytes, with each with its own address. That is because I told you already, now we have data centers in Google and so on, right? It is very easy for us to search a data if it is stored in a very organized way so that you can just pick it up, right? So you need an address. Every time this address is there, I want to show, you know already that this, consider this to be a bit. 1, 2, 3, 4, 5, 6, 7. You have 8 bits. This is 1 byte. And information is stored in this address. Okay, this address will be there so that it is easily accessible by the system. Whenever a processor wants to pick a data from the memory, if you give the address of the memory, the data is automatically fetched without any kind of difficulty. Okay, so memory storage requires a unique identifier. Identifier means it has an unique value. Every memory allocation is unique. It has a unique value, and this identifier is used to find out the location at which the information is stored. So CPU fetches instructions from the memory. Our instruction set is also stored in the memory. So this is my computer. These are the information that I have in my computer. These are the files. So this is PZ. So this PZ will give me the total amount of storage that I have. That is, I have 237 GB available, out of which I have 96.4 GB free. This is Google Drive, which I've connected to my drive. Now here I have this particular area, see, users, window, program files. So this particular thing, Windows, is where I have stored all the operating system files, which is automatically created when you install the operating system. The program files are the application files like the Adobe Acrobat, Microsoft Word, PowerPoint, and so on. These files are being stored in this particular program file. So this is my entire memory. This is the entire memory which is there stored in C drive. C drive consists of 9.61 GB, that is free, and 237 GB. Out of this 237 GB, I have used some programs, say for Windows. I've used Windows, I've installed Windows, so I've used this, and see this amount of 10 GB, it keeps increasing. So approximately so much GB I have allocated it for my operating system. The rest of the files, say in this one, introduction to operating system, here is where I have stored your information. Okay, student information I have stored. Okay. So main memory is divided into two parts, one for the operating system and the other one for the user applications. So now you have understood what is main memory and how data is being stored inside your computers. Now what are the main functions of main memory? First job is to provide the data that is required by the processor in a very fast way. Okay. Next point is that it acts as a buffer between the processor and the secondary storage. How many of you have seen CDs, compact discs? You have seen DVDs. Olden days, previously we had all our movies in form of CDs and DVDs. CD stands for compact disc. How many of you here have seen floppy disks? My first job, my first job was in railways where we used to have a system where we used to collect data from the train, black box for the train. In that times, say in 2004 and 2005, we had used floppy disks. Floppy disks are usually of the size 1.44 MB. Okay, that is inserted into your system. You can store the data. You can take it and use it outside also. So floppy disk itself was a big invention some 20-25 years back. Today, you have pen drives, you have secondary storage devices, so many things, you have cloud storage and so on, so that the need for floppy disks or compact disks are eliminated. Now you don't need to have a CD to watch your movies, right? You can just insert a pen drive and start watching. So all these things are secondary storage devices, pen drives, cloud storages, and so on. So the main memory acts as a buffer between the secondary storage and the processor. When processor wants to give some information to be stored in the secondary storage device, it is done through the main memory, because sometimes secondary storage devices may break out, right? It holds the active process and system applications. It holds the entire operating system functions are being saved inside the main memory. These are the three important functions of main memory. Hardware of the main memory. So here we'll see two important parts of our main memory. One is called as the registers. Registers are the temporary storage devices where you can have an easy access to the main memory. It is small, high-speed storage device units inside the CPU used for temporary data storage and fast access during processing. Okay. Main memory and registers are built into the processor itself and are the only general purpose storage that CPU can access directly. So CPU is going to access only two things. One is called as the register and the other one is the main memory. Okay. So this is the operating system kernel. You have user processors and user free spaces. There are machine instructions that take memory addresses as arguments, but none that take disk addresses. I'll explain to you what this means as we go on in the coming slides. So now, registers are quick access, but processor to access the main memory, it has to keep going through the lot of clock cycles. So in order to, for the processors, CPU, to access main memory, it is taking lot of time. In order to avoid that, what we can do is that we can create something called as cache memory. Cache memory is an intermediary between the processor and the main memory. You have the processor here, and you need to access the main memory. Main memory, you can imagine this to be a long, huge place where you have so much of information that is being stored. Okay. So if the process, this is, let me assume this to be, okay, 1, 2, 3, and so on. These are all analogies. It's not the way it works really. So if this has to access this one, after it has accessed this, then it has to take the entire cycle and come back to one. So it takes a lot of time for the processor to keep accessing the. So in order to avoid the time taken, what we do is that we create another one thing called as cache memory, where all the frequently accessed information is being stored so that the processor can easily access these information. Okay, so that it did not do the entire cycling process. So the remedy what we did is that we added a cache memory between the CPU and the main memory. The process, what happens is that when it has to go, multiple processor coming up, no processor will get blocked. You might have seen that your system gets stuck sometimes. What do you call it? That is called as being stalled because it does not have enough time to access the main memory. So much of information is being asked so that it does not have enough flexibility. So in order to reduce the effect of this being stalled, we have a duplicate one place buffer memory cache. This is called as cache memory, which is easily accessible. Most frequently used information is stored inside the cache memory. So now, again coming to the hardware, memory address is a unique identifier. Unique identifier means, identifier itself means it is unique. It means that there is only one address in a system. Okay, only one place, one address in one system, that is unique identifier used to access a specific location inside the processor. A specific place you want, you have stored your some information, So here you can see that I have a C drive. Inside the C drive, I have folders. Inside the folders, I have files. So each file is allocated a particular memory location. When I click on that file, it gets open because it takes the data from that particular memory location. Okay, so that memory location is the unique, you have that address for that place where it is being stored. Now say here this particular set of slides which I prepared is saved inside my computer in a particular memory location. When I click on that, what happens is that the operating system redirects to that particular exe file. It opens that and shows me the slides whichever I require. Okay. So how can it know that this is the place where I've stored this? I have the identifier as file name. File name is a unique identifier. You agree with me, right? You cannot store two files with the same name, same extension in one particular folder. What happens is the other one is always duplicated. Operating system automatically gives another name for that. Okay, so file names are identifiers. You cannot store same file name in the same location. Two files with the same file name in the location. What it does is that you can see that if I store this memory management is the file which I wanted to save. If I save memory management.pptx in one particular location, the same location, if I want to save memory management.pptx, it does not allow. What it does? It stores it as one within brackets. No? You might have noticed that. So that is because file names are identifiers. Okay, the address space mapping. So we have two types. One is the logical address. Logical address is something what I've told you. The file name itself can be considered to be a logical address which the user knows. I know that my file name is this, but I do not know the physical address where this particular file is stored inside my main memory, right? That will be a unique digital number which is stored. So these both are mapped. Only when these both are mapped, I can access my file using the logical names or logical addresses to the physical addresses where this particular file is stored, right? This is called as address space mapping. We will have separate algorithms written so that the logical names, say I have this file name called as memory management.pptx. This is a logical name, for example. This is having another place where it is being stored, which is a digital address which we do not have any access. That disk address is separate, that is called as the physical address here. Are you all able to follow what I am saying? Physical address in the main memory. So mapping these both is very crucial. You know that for the efficient memory management in the operating system. Address binding. So what is address binding? I've already informed you that. So now we have two types of addresses. One is called the logical address, which is known by the user, and the physical address or the virtual address, which is not known by the user. Physical address, the actual location in RAM. Memory management unit is a separate unit, that's a hardware component which is going to convert this logical address into the physical address. Okay, written down. What is memory swapping? So what is meant by swapping? Swapping means exchanging. One thing over the other, you are just exchanging. Okay. So it is temporarily moved from main memory because you can save some space. It is saved to some other secondary storage device. And when it is required, it is being called for again. This process is called as swapping. Okay, so you are freeing some space that is already available in the main memory that is being utilized. Okay, so why do we need swapping and how to swap? When the main memory is full, what happens is that the operating system will have to be inactive because the operating system, what it does is that if you have a secondary storage device, it moves this to a inactive, takes an inactive process and moves it into a secondary storage because inactive process does not require immediate memory. Okay, so that memory space is freed enough for the whole process. When the process is needed again, it is being called for back. So why do we want to do that? How and why? That's the title of the slide I've given. So what are the advantages we have? It gives you more space in the memory. It helps multitasking by managing memory more efficiently. Disadvantage means as usual you know that it has to transfer from one point to the other. Thrashing, excessive swapping, now it can degrade the memory performance. What are the advantages and disadvantages of swapping? Why do we need to use or why do we need to swap? Next topic is contiguous memory allocation. What is meant by contiguous memory allocation? Very simple. The meaning itself is self-explanatory. One part of the memory, one whole part of the memory is being allocated for one particular process so that it is very continuous and it is very easy for access. Okay, each process is contained in a single section of the memory that is contiguous to the section containing the process. Methods of contiguous allocation. How is contiguous allocation done? There are two methods with which you can allocate memory in a contiguous fashion. The first one is called as fixed partition, where the memory is divided into fixed sized partition. So each process is allocated one particular location. The advantage of fixed partition is very simple because it is directly very easy to implement. Leads to internal fragmentation. That means you have a lot of waste space inside the memory that is allocated to a particular size. Variable partitions. Based upon the requirement of each process, the amount of memory is being allocated. That is called as variable partition. How much ever is required for you, only so much is given to you. So that type is called variable. It reduces the wastage. But what happens is that the process becomes more complicated and may cause external fragmentation. External fragmentation means what? Sometimes it is fragmented although it is not required. There is spaces that is not required. Sometimes it is not used at all. Okay. Unused gaps between different allocations. Okay. You understand what is external fragmentation? Unused gaps between different allocations. So, thank you very much. Any doubts on this?